Hello, I'm Michael Brinker,
Hello, I'm Brent Begay.
and our desired professions are electrical engineering.
Electrical engineers' duties are to design, maintain, and improve products that are powered by or produce electricity.
What they bring to any team of engineers is their detailed knowledge of circuits, programming, hardware, software, as well as specific parts of physics that pertain to electrical and magnetic properties.
Electrical engineers can work almost anywhere, from labs and offices to mines and industrial plants. Their work often has them supervising others, managing projects, and meeting with clients. Common daily activities include meeting with project members and managers to discuss tasks and redesigns. Then we'll finalize the draft where they individually work on parts and submit by the deadline. One other field electrical engineers can go to is computer/electronics engineering. They work with other engineers to design, develop, and manufacture computers, integrated circuits, and other computer components.
Another occupation electrical engineers can go into is power plant technology. They can work with other engineers to design, redesign, and implement power systems. This includes the management of current power plants or power grids, as well as new ones and how they will fit into the new design. The type of data that electrical engineers will deal with are, for example, voltage output, resistance of parts, magnetic field generation or stability, reliability of certain parts, and the power consumption of parts or systems.
Electrical engineers will use statistics when collecting data to determine which component works best, as well as which components work best together. Also, they can use data to determine the failure or success of a certain part.
Solar power is the process of taking solar radiation and converting it into electrical energy. How to make solar energy economical is deeply connected to electrical engineers as it has to do with electrical production, which our field specializes in. One thing we can do is to try to increase the power output to surface area ratio.
Fusion is the process which powers the sun and the stars. It's the energy that makes life all possible. It fuses light atoms at high pressures and temperatures. The gases will form into plasma, then electrical engineers will convert energy from plasma, which will be used for power.
For reverse engineering the brain, electrical engineers can help decode the electrical signals that the brain sends to the rest of the body, as well as signals sent between neurons. They can also find ways for the signals to communicate with computers and vice versa. Like reverse engineering the brain, enhancing virtual reality will also have to deal with communicating and interpreting brain signals. One solution is for electrical engineers to create a device to tap into the optic nerves to send data directly to the brain, so it will interpret it as what our eyes would actually see. So the virtual reality will seem like reality.
Similar to the optics, we can tap into the motor signals of the brain and transfer those signals to the virtual avatar. But we will also have to find a way to block those signals to the body so people don't hurt themselves while in virtual reality.
So we're creating the Matrix, aren't we?
Yeah, pretty much.
Okay, so this won't end badly. No, not at all.
One example for engineering the tools for scientific discoveries are long-range space probes. The probes can't communicate too well with Earth because of the distance. So electrical engineers can work with others to create a system or program to give it problem-solving capabilities.
Another challenge is preventing nuclear terror. Now, we couldn't really think of any other ways to do this, but railguns. Railguns are cool, right? I mean, come on. Shoot projectiles at high speeds and create craters the size of canyons? It's awesome. Come on.